let's look at what is hyperparameter and hyperparameter tuning in this video. Let's first recap and understand the data splits that we have. We normally split our dataset into training, validation, and test. Normally, we'll use training dataset for learning. This is what we'll use to train the model. Then, if we have multiple trained model, we'll use validation dataset for decision making. To pick one among those many models that we have trained, we'll use validation dataset. And test dataset is normally used to publish the final outcome to the outside world or to the end user. So they know the performance of our model on an unseen data. So that is how we'll use these three standard splits normally. And let's also recap what is a model selection. Model selection is basically choosing one of many models from same algorithm or architecture. So if we take decision tree as an example, if we have multiple decision tree models that we have trained, and then if we pick one of them based on their performance, then that process is called model selection. And on the other hand, model comparison is where we'll have different models from different architecture or algorithm. So this could be things like decision tree or some other algorithms and architecture. So we'll have different models from different algorithms and architecture, and we'll pick one of them based on their performance. So this process is called model comparison. Again, this is not a universal definition. This is a definition that I keep using to differentiate between same algorithm and a different algorithm selection process. Now let's focus on model selection. Okay, so this is where hyperparameter comes into picture. So let's focus on how model selection works in practice. So let's quickly recap on how training process works. Okay, so we will select the architecture or algorithm. In this case, we have selected decision tree, and we use the data that we have. We use the training data that we have to train this model. So during training, the decision tree will learn how to produce our expected outcome from the input data. And because this is a supervised learning, we'll also have this feedback loop where the outcome will be fed back to the model, so the model can do the error correction during the training. Here, during the learning, the model figures out its internal parameters or configurations, right? If we take decision tree as an example, it works out what kind of decision nodes it needs to have, and it works out what kind of leaf nodes it needs to have. So all of those things are parameters. Okay, so these parameters are basically learned from data during the training process. So like I said, it includes things like decision nodes, leaf nodes, and all these things. So these are basically learned from the data. If we use different data, most likely we'll have different type of decision nodes and leaf nodes. Okay, because this is driven by data. It is extracted or learned from the data. That is the important thing about parameter. And the trained model is basically the architecture or algorithm plus the parameter learned from the data. So the combination of these two is basically our trained model. On the other hand, we have something called hyperparameter. Hyperparameter is something which is not learned from data. Instead, it is rules about learning. We specify these rules upfront. When we are training the model, we specify these rules, and the training process has to honor, or it is constrained by these set of rules. Those things are called hyperparameter. An example for this is depth of the tree in case of decision tree. When we are training a decision tree, we can specify what should be the depth of the tree. Okay, depending on the size that we choose, the model is going to be very different. If the depth is shallow, then the tree might be simple. But if it is deep, then our tree might be very detailed. So depending on the depth that we choose, the model is going to be very different, even though we have the same data. Even if we use the same data, the model will be very different depending on the depth that we choose. So these type of parameters that we specify upfront, even before the training is starting, is called hyperparameter, because these are parameters that are not learned from data. So I just want to reiterate here, the hyperparameter are chosen before the training process begins. Okay, so that is the important difference. And hyperparameter is not learned from the data. It is set by someone who develops the models. Someone who is developing these models will decide what kind of hyperparameter to choose, and they will actually set that at the beginning of the training process. And depending on the hyperparameter that we choose, we may have very different model even if the data is same. Even if the data is same, the change in hyperparameter will lead to different model. Okay. Now let's understand why we need hyperparameter. Normally, in case of decision tree, if we increase depth, we can say that it increases the accuracy, because the more depth that we have, the decision tree will be able to make detailed and more sophisticated decision branches. With those detailed sophisticated decision branches, it will be able to come up with better accuracy. But it doesn't mean they'll have better generalization, because more accuracy is not about generalization. If we have deeper tree and if the accuracy is high, all it means is that it has learned the data so well, it has learned the training data so well. It doesn't mean that it will perform well on unseen data. So there is no guarantee that we'll have good generalization. So what we need is, we need a way to choose correct depth, which is our hyperparameter. We need a way to choose correct depth that balances accuracy and generalization. We want high accuracy, at the same time our model to be generalized enough so it performs well on unseen data. And the choice that we make has to be data driven and evidence based. We can't just guess them. We don't want to guess them. It has to be data driven and evidence based. So we'll be able to make better choice for our hyperparameter, in this case our decision tree depth. Now how do we do it? Okay, so now we know that we need to pick right hyperparameter in order to get the best result or best model. But how do we do it? Normally the way we do that is, we'll choose some set of values and we try creating different models using those values, and then we'll pick one best performing model among them. Okay, so if we take decision tree as an example, and if you want to choose the depth of the tree as hyperparameter, then we will pick some candidate values. So these are candidate values for depth. It could be any number of lists. In this example, we have these 5 values. Then with these 5 values, we'll create different models. We'll train different models. The data will be same. We'll be using the same data for training, but it's just that we will have different hyperparameter, which is the tree depth, during our training. So we'll have 5 different models because we have 5 different candidates for our hyperparameter, which is tree depth. Now, once the models are created, we'll use our validation dataset to validate each of these models, and then we'll publish the validation result. And based on that validation result, we'll pick one final model, which is the best model. And whatever was the hyperparameter that we have chosen for that model will be the hyperparameter of our choice. Okay, so this process is called hyperparameter tuning, because we are actually tuning the hyperparameter or selecting the hyperparameter which is performing the best. Okay, once we have selected our hyperparameter, what we will do is, we will do one final training, and in that final training we'll have both training data and validation data. We'll take both training and validation data. That will be our one final data set, and with that data set we will train the model again, and this time we will use the best hyperparameter that we have chosen. For example, if that is hyperparameter 12 for decision trees depth, then that is the hyperparameter that we will use, and the dataset will be slightly expanded to include validation dataset as well, and that model will be our final model, and we will publish the performance of that model to the outside world using the testing data or test dataset. That is all I wanted to talk about in this video. I hope this is useful. Thank you.